All right, this is 8-2, day 2, and I thought I'd go over this quickly. We're going to kind of skip some of the calculator work, but I will discuss the values, of course. Find the component form of vector AB with the given initial and terminal points. -2, 5, 3, -6. Well, we subtract, we do x2 minus x1, y2 minus y1, and we get an answer of 5, -11. Find the magnitude of vector AB with the given initial and terminal points. So we want the magnitude, so we have to get the component form first. So -2 minus 3, 1 minus 8. So we get -5, -7. And then to find the magnitude, we do the Pythagorean theorem. So it ends up being square root of 74. Find a unit vector with the same direction as the given vector. So W is -3, 6. So we have to find the magnitude. Pythagorean theorem, square root of 9 plus 36. That's square root of 45. And then you can pull the 9 out. So that is square root of 9 times 5. So that's where you get 3 square root of 5. And then divide each component by the magnitude. And we do a little simplifying now. If this happened to be a multiple choice on the test, you might have to know that it's negative square root of 5 over 5 and 2 square root of 5 over 5. You know, if we have to rationalize the denominator. Let vector DE be the vector with the given initial and terminal points. Right, DE is a linear combination of the vectors I and j. So we have to get the component form, 3 minus -6. So x2 minus x1. And y2 minus y1. And there's the component form. And then it's just simply 9i minus j. And really it's 9 times 1, 0. Minus -1, actually plus -1 times 0, 1, like that. So that's the I, and that's the j, but this work right here is just fine. Find the component form of v with the given magnitude and direction angle. So we have 7 cosine of 38, 7 sine of 38, and when you plug the calculator in, make sure you're in degree mode. Not radians, because we're using degrees. And you get 5.516 and 4.310. Now over here, we know about 210. It is one of the pi over 6s. And so 210 is negative square root of 3 over 2 and -1/2. So the cosine of 210 is negative. There's the negative right there. 24 square root of 3 over 2, and then 24 times -1/2. So you get -12 square root of 3 and -12, because 24 divided by 2 is 12. Find the direction angle of each vector to the nearest tenth of a degree. Well, it's nice to know where you're at, where that vector is. So here's 5, -3, very roughly. So we take the inverse tangent of y over x, but it gives us -30. -30.964. Well, we don't really want that. We want positive values. So we add 36 to that. So the unit circle measurement is that 329. Here's 2, 5, very roughly. So inverse tangent of 5/2 is 68.199. First quadrant is very much a principal quadrant, so we really don't have to do anything with that. Here's -3, -8, roughly, and inverse tangent of 8/3 is 69.444, so the calculator thinks we are actually in the first quadrant. We're not, so we're going to add 180 to that, and we get 249.444 degrees. I thought this one I could go through a little bit slower. An airplane is traveling 250 kilometers per hour, 35 degrees south of east. Let's get the plane. So 35 degrees on the south side of east. All right, let's draw the plane like this. This right here is the 35 degrees, and that's certainly not the unit circle measurement. Let's get the unit circle measurement. If we go start at the x-axis, go all the way around, we're 35 degrees short of 360. So that's 325 degrees, and the magnitude is 250. Here's the wind. Let's see, a wind is blowing 28 kilometers per hour from, that's an important word right there, from 70 degrees south of west. So 70 degrees south of west is like that, so the wind is actually blowing something like that in that direction. So the magnitude is 28. Now if this little piece right here, well actually, if this is 70 degrees, then the unit circle measurement must be 70 degrees also. Now what we're trying to find is the resulting path right there. So let's get the plane. The plane is 250 cosine of 325 and 250 sine of 325. The wind is 28 cosine of 70 and 28 sine of 70. And we're going to add those two together to get the resulting vector. Let's do that. Grab the calculator, turn it on, clear. And we got 250 cosine of 325 plus 28 cosine of 70. So I'm getting 214. Where'd my cursor go? There it is. So this is the resulting path, 214.365, and keep on going to that, but I'll put that in A. Let's store in A. And then we'll go 250 sine of 325 plus 28 sine of 70. And we get negative 117.00827. Keep on going like that. And we'll put that into B. So store alpha B. Well, now let's get the magnitude. The magnitude of R is equal to the square root of A squared plus B squared. So we have square root of A squared plus B squared. That's 244, so 244.255, and I'm thinking, oh, kilometers per hour, not knots this time, kilometers per hour. And then the angle is inverse tangent of B over A. So inverse tangent of B divided by A. And we get negative 28.643, but that's going to be on the south side of east, because that's how it's given here. South side of east here. Well, that's on the south side of east. So 20, if we round 29 degrees south of east. Fred is walking around his neighborhood. He walks north for 7 blocks, east for 10 blocks, and then turns left for 8 blocks. Express Fred's walk as a linear combination of units vectors I and j. So if he walks north, if we go straight north this way, and if this was the xy axis, this point up here would be 0, 7. So we have 0, 7. East for 10 blocks, so east 10. So if this was the new x and y axis, this point would be 10, 0. So we have a component form of 10, 0. And then turns left for 8 blocks. So left this way. That's actually north, so this would be 0, how many blocks? 8 blocks again. So here's 0, 8. So express Fred's walk as a linear combination. So 0 plus 10 plus 0 is 10. 7 plus 8 is 15, so 10i plus 15j.